So this is the notes for Chapter 2, Section 2. We are working on characteristics of quadratic functions. Okay, so far you should know a little bit about quadratic functions already. For one, a quadratic function always has an x squared in the equation. Sometimes the x might be in parentheses with a tiny 2 on the outside, like it might say x minus some number. That number would be the h. It might be an extra number here. That's a K. It might be an extra number in front of the parentheses. That's an A. We've already discussed those things. And the graph of a parabola is a U-shaped curve. A graph of the quadratic function is a U-shaped curve called the parabola. So this is a parabola. It's a U-shaped curve. Okay? All right. So on the next slide, first of all, you need to know when the axis of symmetry is. The axis of symmetry, according to your book, is a line that divides the parabola into mirror images and passes through the vertex. So in the diagram, the red line right here, that is the axis of symmetry. Okay? And what you should notice, for one, is that the axis of symmetry splits the parabola in half, goes right through the middle, and it always passes through the vertex. Okay? What's a vertex? A vertex is the point at the bottom of the parabola, or the U, which is your HK. So this point right here, I'll make it black, right there. See that? That's the vertex. That point right there is the vertex. And see how it says HK? So when you were finding the HK in the equation, you were actually finding the vertex of the parabola. Now also, your book says that the axis of symmetry is the vertical line x equal h. So whatever your h value is, once you find h, if I ask you for the axis of symmetry, you'll tell me it is x equal and then whatever the h number is. Okay? What do you mean, Miss Bay? Well, I'm going to show you on the next slide. So here's an equation. This equation is in vertex form. So let me go back. Anytime your equation, your quadratic equation has the x in parentheses and another number and then something else on the outside of the parentheses, that is vertex form. When it's in vertex form, that means all you have to do is look at it to find out your h and k, which is the vertex. You can also see the a value, okay? So remember, the a is right in front of the parentheses. Let me go back. H is in the parentheses with the X, but you always switch the sign of the H number. And then K is on the outside. So we know that A is, see, -2. H is -3. And K is 4. Okay, so we have A right here. There's A. Here's H. And here's K. Now, the A value determines if your parabola is going to get skinnier by stretching or wider by compressing. And it also tells you if the parabola is going to flip upside down, which is a reflection. Since our A value is -2, the negative is what makes the parabola flip or turn upside down. And the 2, anytime your parabola is bigger than 1, that means it's going to get skinnier. So your regular parent graph of the parabola might look a little something like this, but sometimes our parabolas get skinnier or wider, and sometimes they flip upside down. The vertex of the parabola is -3, 4. Remember, we got that from H and K. So our vertex is HK. The axis of symmetry is -3. Remember, we got the -3 from the H. Axis of symmetry is always x equals h. That's review, okay? Except for number 3 and 4. Number 1 and 2 is review. You should know that already. On the next example, so A is 0.5, H is -4, and K is -2. We see that from the equation. So again, I'll write it. Here's A, here's H, here's K. Remember to switch the sign of the H. My K looks really ugly. The A tells us that the graph is going to compress. So this time the A value was not a negative, so it did not flip upside down. And 0.5 is less than 1 whole, so instead of stretch, the graph will compress. That means the parabola got a lot wider than the parent function. The vertex of the parabola is -4, 2. That's your H and K. And the axis of symmetry is x equal -4. That's your H. So, like I said earlier, vertex form of a quadratic equation looks like this. And that's when you have the x in parentheses with another number and then something else on the outside, etc. All you have to do is look at the equation to find the vertex because you should see the h and the k. However, all the equations are not in vertex form. A lot of times they are in standard form, which looks like this. So basically, if I took the vertex form of an equation and I multiplied it out, I did order of operations by getting rid of my parentheses, doing exponents, etc., I would get an equation that resembles this. Your a value will still be in the equation. It is always the number in front of x squared. But then you'll have a second x term, an x number with no exponent. The number in front of the x would be b. And then the number on the end with no x in it at all, that would be c. Okay? What is c? The c value, the c value is, did I not have it here? Oh, yes, I did. The c value is the y-intercept of the graph. What's a y-intercept? Remember, a y-intercept is where the graph crosses the y-axis. And it's whatever the equation is when x is 0. So let's say you have, let me draw a little something. So let's say I have a graph like this. And let's say my parabola did one of these numbers. Okay. So this point right here, where the curve touched the y-axis, is called the y-intercept. Okay, let's say that point is 0, 2. So our y-intercept would be y equal 2, or you would say 0, 2. Okay, the h value is not visible when we're looking at the equation in standard form. There's no h, but we can find the h. We can find the h value by taking b and dividing by -2a. -2a means -2 times a. Okay, and I also put that right here for you. To find the h value, so let me draw an arrow. You take b, wherever b is in your standard equation, put it on top, and divide it by -2 times whatever the a value is. And then just simplify. And that would be your h. Once you know what h is, that would be your axis of symmetry. Don't forget the axis of symmetry is x equal h. To find the k value, you gotta know what h is. Once you know what h is, you're going to evaluate the function by plugging in the h for the x. What do you mean, Miss Speight? I mean, right here in the whatever your standard equation is, all of those x's, you will take it out and put in whatever number you got for h, and you will do the math. And I'm going to show you on the next slide how that's done. Okay, so it says find A, B, and C. Notice this equation is in standard form. There is no parentheses squared. That means it's in standard form. We do not see H and K. You should see A though. A is the number in front of the x squared. So A equals 3. B is in front of the middle term, the x number. So B is -6. Make sure you watch your signs. It says -6x. And C is the number with no x in it at all. C is 1. Describe the shape of the graph by the A value. Okay, here's the A value. Because A is 3 and it's positive, it does not flip, but it will stretch. Now, I want to note, if A was negative 3, it will still stretch, but it will also flip upside down. The 3 is higher than 1. So when you look at the A value, just look at the A number without the sign, and that tells you if it will stretch or compress. The y-intercept of the graph, remember C is your y-intercept. Since C is 1, our y-intercept is 0, 1, or you could just say y equal 1. How about H and K? So let's start with H. Remember, to find H, you're going to do, B divided by negative 2 times A. All right? So our B is negative 6. That goes on top. Negative 2 on the bottom. Our A is 3. And we're going to do the math. So the top is negative 6. And the bottom is negative 2 times 3, which is also negative 6. And negative 6 over negative 6 is 1. So far, we know that H is 1. Okay, what about the K? Remember, to find the K, what did it say on the previous slide? Evaluate the function by plugging in H for X. In our equation is 3x squared minus 6x plus 1. We are going to take out the x's and plug in H. So let me put parentheses here. So everywhere it used to be an X, I'm going to put a 1. See that? We're plugging in 1 for the X, and then we do the math. Now, if you have a calculator, just put this in the calculator just the way it looks. Parentheses, exponents, everything. Without a calculator, I'm using my mental math, so I know that order of operation, I have to do parentheses and exponents first. So 1 to the second power is 1. And 3 times 1 is 3. And 6 times 1 is 6. And I'll bring down my plus 1. And 3 minus 6 is negative 3. And negative 3 plus 1 is negative 2. So K is negative 2. So, this disappeared when I switched screens. Okay. Since H is 1 and K is negative 2, then right here, when I asked you for the vertex is HK, which is 1, negative 2. The axis of symmetry is X equal the H. So axis of sim is X equal 1. Okay? Next slide. Okay, so again, find A, B, and C. Here's A. A is 0.5. Here's B. B is negative 4. And here's C. C is negative 2. Describe the shape of the graph by the A value. The A is 0.5. That means the graph is going to compress or get wider. It does not flip because the A was not a negative. The y-intercept of the graph, remember C is your y-intercept. So our y-intercept is 0, negative 2. Or if you just want to say y equals negative 2, that's cool in the game. Dang, negative 2. There we go. There. Find the H and K. So we got to do the math. Don't forget H is always B over negative 2 times A. B is negative 4. Negative 2 times A. A is 0.5. So negative 4 over negative 2 times 0.5 is negative 1. And negative 4 over negative 1 is 4. So far we know that H is 4. Our K, we take our equation, 0.5 x squared minus 4x minus 2. We plug in the h for the x, and we do the math. And I'm being lazy right now, so I'm getting ready to put it in my calculator because I just don't feel like doing mental math. So 4 squared is 16. I could do it in my head. 4 squared is 16. 16 times 0.5 is 8. Negative 4 times 4 is negative 16. Bring down my minus 2. 8 minus 16 is negative 8. And negative 8 minus 2 is negative 10. So K is negative 10. So what's my vertex? My vertex is 4, negative 10. That's the vertex. And the axis of symmetry is x equal 4. Okay? And I believe that was the last slide. Make sure you turn in these notes on Google Classroom and make sure you save a copy for yourself in your Google Drive. If you claim you did your notes on paper, take a picture of your notes and send it to me on Google Classroom. Any questions, please send me a message. Otherwise, have a good rest of your day.